You have for a couple of years been familiar with a rational number. Today we're going to learn what an irrational number is, and we're going to learn how to look at a number and tell whether it's rational or irrational. So what I want you to see here, this is a Venn diagram. Okay, you're probably, or you may have seen Venn diagrams before that were circles or overlapping circles. This one is just rectangles, and notice I have rectangles inside of rectangles and I have divided rectangles. That's going to be important. Now, you started when you were little, you learned how to count, right? And your parents were so proud and they'd say, count to 10. And you'd go 1, 2, 3. You were actually learning what is called the natural numbers. And the natural numbers start with 1, and they're any number you can count with 1, 5, 1, 2, skip a few, 99, 100. Anything that you can use to count is a natural number. And then somewhere along the way in a math class, somewhere, someone told you there was a number called 0. And when you add 0 to the natural numbers, you get the whole numbers. Okay, so notice here that the natural number group is inside the whole number group. So every natural number is also a whole number. Well, then you were just fine and you got to about 6th grade, maybe 5th, but someone told you there were such a thing as negative numbers. And the integers are all the whole and natural numbers and their opposites. So 5 is a natural number, negative 5 is an integer. 27 is a natural number, negative 27 is an integer. Notice the progression. Every natural number is also a whole number, and every whole number is also an integer. And then somewhere along the way, you learned what may be not quite your favorites, and you introduced fractions and decimals. And those are called rational numbers. Notice that rational has the word ratio in it. These are numbers that can be written as fractions, and it specifically is a special type of fraction that the definition gets a little weird, but the basic definition is can be written as a fraction. It's a ratio. So these include obviously fractions. So 2/3, negative 5/7, 1 and 2/5. Okay, this includes your terminating decimals, so 0.25, right? You know that you can write that as 1/4. This also includes repeating decimals, so 0.333, or we would just write that as 0.3 repeating. That can be written as a fraction. That is 1/3. So it's important to know that rational numbers can be terminating decimals, or repeating decimals, okay? Now, perfect squares go over here too, right? If I need to find the square root of 49, well, the square root of 49 is 7, right? So that's actually a natural number. So the square root of 49 is a natural number. If I need the negative square root of 81, the negative square root of 81 is negative 9, right? That would be an integer. So all your perfect squares go in the rational side. So all these go together. Natural numbers, whole numbers, and integers are all rational numbers. But today we're going to introduce, or actually name, you have seen them before, what an irrational number is. The most famous irrational number is pi. You're familiar with pi. And what makes a decimal or something like that irrational is it doesn't terminate and it doesn't repeat. Pi never ends. It never repeats. It never terminates. It is an irrational number. Your non-perfect squares, or the square roots of non-perfect squares, are irrational numbers. So the square root of 2 is irrational. If you find the exact square root of 2, which is actually impossible to do, it never terminates, it never repeats. Okay, so there are decimals over here. If I have 0.4132 dot, 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 there's no pattern there, there's no repeat there. That just means it goes on forever. That is irrational. And ones like this, if I have 0.171171117 dot, 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 there's a pattern, but that is not a repeating decimal. It's going to go in that pattern forever, but the same thing doesn't repeat over and over, so it's not repeating. So it's important to note that an irrational number is non-terminating and non-repeating. Now, notice the bar between these two things. A number cannot be rational and irrational at the same time. It's one or the other. Also notice that you put them together, and all of these together form the real number system. Every number on the number line is a real number, and every number on the number line is either rational or irrational. So every number you are familiar with that you have ever worked with in your life so far is a real number. So here's what we're going to do with this. You're going to be given a number. You're going to answer whether it's rational or irrational, and you're going to answer why. So -3/4, is it rational or irrational? It's rational because it's a fraction. It's a normal fraction, okay? So that's a rational number. Next, 0.672 or 672 thousandths. Is that rational or irrational? That's a rational number because it's a terminating decimal. The next one is pi over 2 or pi divided by 2. Now here's where you have to be careful. That looks like a fraction, but if I take pi, which is never ending and never repeating, and I divide it by 2, is it all of a sudden gonna terminate or repeat? No. So pi over 2 is irrational because it is a non-terminating and non-repeating decimal. So even though it looks like a fraction, you take pi, you divide it by a number, it's still going to be non-terminating, non-repeating. Okay, you tell me 1.8 repeating. Tell me, is it rational or irrational? It's a rational number. Now tell me why it is rational. It's rational because it's a repeating decimal, and every repeating decimal can be written as a fraction. Okay, square root of 3, rational or irrational? The square root of 3 is irrational. Now tell me why. It is irrational because it's the square root of a non-perfect square. Okay, look at this, 0.232332333 dot, dot, dot. Rational or irrational? It is irrational. Tell me why. It is a non-terminating, non-repeating decimal. The square root of -4. No, I'm sorry. The negative square root of 4. Rational or irrational? It's a rational number. Tell me why. It is rational because it is the square root of a perfect square. All right, this next one is a thinking problem. Let's see how you do. I have pi plus 1 over pi plus 1. Tell me, is this rational or irrational? That is a rational number. Did you get that? Okay. If you didn't, change it to rational. Now look at it and tell me if you know why it's a rational number. What happens anytime we divide something by itself? We get 1, right? Pi plus 1, all divided by pi plus 1 equals 1 because it's something divided by itself. So since this simplifies to an integer or a whole number or a natural number, which is 1, it is a rational number. So just because something has pi in it doesn't automatically make it irrational. Make sure you look and see if something happens that you can simplify and the pi goes away.